On this one, we're going to calculate equilibrium concentrations, but it has a few things that are kind of different. For one thing, these are gases, and it doesn't give us a molarity for them, but that's what we need. We need concentrations. And it may seem kind of strange because we use molarity usually for solutions. It's moles per liter, but you can use that for a gas as well. So the first thing I'm going to do is convert these to a molarity. And that is the concentration of C, the initial concentration of C. So that brings up the other thing that's different. Instead of starting with reactants, I'm starting this reaction by putting some C into a container to see what happens. So my initial for C is this 1.92 molar, and I'm starting out with no A and B. So it's kind of just written backwards, but I'm starting with my product, and it is going to react to the left to get me some equilibrium concentrations. So it kind of changes how I set this up. The change will be here, I'm going to be losing some, and I could say minus X, but then that kind of complicates what to do with these. So I'm going to stick with our general pattern of using this to say minus 2x here, and that way I know that for every 2 moles of this, I'm going to gain 1 of that and 1 of that. So again, just using the coefficients to get those numbers in front of the x. Then at equilibrium, again, I'm adding these two. Okay, so I have my expressions for my equilibrium concentrations, and I also have an equilibrium constant. And my goal is to solve for x so I can find out what these concentrations are. Particularly, I want to know what A is. So I'm essentially going to be solving for x, because x is my concentration of A. So let's set up our equilibrium constant expression, products over reactants. But then, of course, we watch, when we set these up, we need to watch for these coefficients. Here, that coefficient of 2 is used to square this. Okay, and so I know some numbers, some things to plug in. I'm going to plug in my known equilibrium constant. And here I'm going to plug in these x values. Okay, and my goal is to solve for x. And so I have these things that x is squared, and it would be nice to get rid of those. And so one way I can do that is by taking the square root of both sides. And when I do that, I'm going to have plus or minus on this side the square root of 51, but on this side I basically get rid of the squares. So oops. Okay, and then I can continue, and I'm going to go ahead and take that and multiply both sides by x. and at this point I'm going to put in the two possibilities because that can be plus or minus there. So I'm going to write them over here. Let's see. I need to find both roots, both possibilities. And I got this by saying 2x plus the 7.14x, that's how I got the 9, or 2x minus, that's how I got the 5 there. And I can see here that I'm going to get a negative number here. And a negative number is not possible. So I know this one is not going to be it. If you look up here, you know why it's not possible. We can't like have negative values for these concentrations. Okay, and then we were asked to find the equilibrium concentration of A, and according to what we set up, that's X. And so the equilibrium concentration of A is